So in this video, I will be solving for the temperature of an adiabatic flame through this problem right here. So to start off, I'm just going to draw a little diagram of what is going on in this problem. So we have the natural gas coming in. Natural gas coming in, and then that's going out. To our flame. And then from the other side is air coming in. Also going to the flame. And then now I'm just going to write down some of the things that we know going into this. So we know it's at a steady state. We know that the natural gas is 95% nitrogen, or methane, 95% methane. And 4% ethane. And 1% propane. And then there was also 20% excess air. And the air percentages is 79, we're going to use 79% nitrogen and 21% oxygen. And then also we know that it is an ideal gas as well. So one more known that I forgot to write was that the change in heat will be equal to 0. And so now what this steady state means is that the enthalpy in for some amount of mass that we're combusting is going to be equal to the enthalpy out for some amount of mass coming out. So now I'm going to write out the combustion reactions in order to get our moles of each species using the stoichiometry of the reactions. So our first reaction is going to be using methane. So just a normal combustion reaction, CH4 plus O2 will be producing CO2 and H2O. And then one more thing in these reactions is we have our nitrogen and excess air that is just along for the ride as well. So we'll have nitrogen on both sides as well. And now we just have to balance this. So let me give us a little bit more space here. So we have one carbon on each side, and then for the hydrogens, we can put a 2 here to balance out those hydrogens, and then a 2 here to balance out the oxygens. And now, although this is balanced, we have not taken into account our 79% nitrogen and 21% oxygen. So in order to do that, we are going to have to put that coefficient here in front of our nitrogen. So it'll be 79 over 21 of that nitrogen. And then that as well over here. So one thing I forgot to take into account here was that there's a 2 in front of this oxygen. So that means for our ratio here, for the air, we need 2's here as well in front of both of these. So now we can do another reaction, but this time with ethane. And it will be a lot like the one from ethane, being just a normal combustion reaction. O2 and with the nitrogen along for the ride again. And so this time, in order to balance this, we're going to need a 2 in front of here to balance the carbons, and a 3 here to balance the hydrogens. So then this oxygen is we're going to need 7 oxygens. So we can actually just put a fraction here of 7 over 2 in order to get 7 oxygens. And our nitrogens are balanced. So this is all balanced again. But again, we need to take into account our percentages of the air, 79 and 21. So we're going to do that again and put it in front of the nitrogen. And again, we're going to need this 7 over 2. So this will be the ratio of the nitrogen to our oxygen. We're going to put that in front of both. 79. And 7 over 2. So these are our 2 reactions with the stoichiometry to help us figure out the moles of each species in this abiatic flame.